Hello everyone, this is a supplemental video lecture for the Unit 2 PowerPoint slides, which I am looking at on my other monitor. Unit 2 corresponds to the chapter readings by Baumgartner and colleagues. It does not appear as if many of you have read that chapter from my tracking software on eCampus, so this is a little bit of a concern for me, given that the next quiz is quiz 2 is going to be covering chapter or unit 2, and quiz 2 is on the 25th. So this is quite a concern. My general philosophy about quizzes and tests is that oftentimes you need to read the readings, the assigned readings, at least twice, sometimes 3, maybe even 4 times, in order to retain the material in a manner that's sufficient for a traditional closed book multiple choice exam. That being said, this is an open book exam, and you are timed on quiz 2. So it's a little bit of a different setup, but nevertheless, you do have to be familiar with what's in there. If you're going to take an open book exam, the challenge is, and especially a timed open book quiz such as this, the challenge is that you need to know exactly where the material is, and you cannot spend a lot of time looking up material. And if you haven't read the material, then that's going to be a difficult task, and you may not even finish the quiz in time. So I strongly suggest you read that chapter for Unit 2 and at least once in preparation for Quiz 2, which is again next week on June the 25th. Quiz 2 will cover Unit 2, and you will also have Unit 3 notes uploaded about the same time. So again, I think it's very important for you to have done that reading. So that being said, I'm going to proceed into a discussion of the notes, and you'll notice that I'll be looking away at times and looking at the opposite screen. Beginning with slide 2, the outline. This Unit 2 is a basic overview of the scientific method and research process. Discusses research questions and problems, types of variables, cause and effect relationships, really going to be explored more in Unit 3. The role of theory in research and what a hypothesis or hypotheses are, and conceptual and operational definitions. So proceeding to slide number 3. The basic scientific process goes through traditionally we'll go through a series of steps, oftentimes beginning with a research problem or question. So for instance, in my own research, my question, the problem that I'm trying to explore is, how do you promote physical activity? How do you increase physical activity for individuals across the lifespan? What are some ways that we can encourage the initiation and long-term maintenance of physical activity behavior? So that's a research problem. Clearly has public health implications, especially with all of the diseases linked to an inactive lifestyle. So finding ways to promote the initiation and long-term maintenance of physical activity is a research problem. So what I've done then is I've formulated several hypotheses, namely that mental imagery can be used to increase physical activity behavior. I've designed several experiments, really community-based experiments. That is in accord with developing the research plan under the third bullet point under slide number 3. I typically will design a program as part of that research plan, a program of mental imagery, or in some cases I've developed peer-based interventions that help to promote physical activity behavior. We will then do a pre and post test on participants, measure their physical activity or their fitness or their motivation for physical activity behavior. And from that pre and post test data, that's under the fourth bullet point, collecting and analyzing the data, we can determine whether or not, this is my cat Sadie, I apologize, she doesn't like it when I work. So from that I can determine whether the intervention was successful or not. And I can interpret the results of that experiment, that peer-based intervention, or it may be a mental imagery intervention. So that's an example from my own research about the traditional scientific method that is presented by Baumgardner and colleagues in Chapter 1. That's a basic overview of the scientific process. So proceeding to slide 4. Now, I'm not going to answer many of these questions that are embedded in Unit 2 PowerPoint slides, but I will answer some of them. So research questions. Oftentimes research questions can be descriptive in nature. They can assess differences, or they can assess relationships. Now, what does all that mean? Well, descriptive research is simply that. It's describing a given problem, the nature of a given problem. For instance, the Centers for Disease Control and Prevention every year conducts a national survey of phone-based survey of citizens in the United States, and it's called the Behavioral Risk Factor Surveillance Survey. Basically, they take a sampling frame, which is they'll take up to 1 million names in the phone books of people across the country, adults with telephones, and randomly select people from each state to telephone. And they'll ask them a series of questions about their whether they've been told by a doctor that they have coronary heart disease, whether they've been told by a doctor they have diabetes or arthritis, and then they'll assess risk factors associated with those various diseases, such as inactivity, their body weight, how much alcohol they drink, etc., etc. So basically what that does, and you can find this data, if you take my physical activity promotion class, SEP 415, we do a project that focuses on the Behavioral Risk Factor Surveillance Survey. And basically what they do is they can chart the prevalence of people's self-reported alcohol use, physical activity behavior, a whole range of variables. And then you can correlate them. But the first part of that really shows the prevalence of population-based estimates of various diseases and risk factors for diseases. So when we talk about prevalence, that is descriptive research. So the very first question under slide 4, or the only question under slide 4, what are the differences between descriptive, difference, and relationship questions? The BRFSS data is descriptive in nature, okay, by charting prevalence. Now, other examples of descriptive research, several years ago I did a study of, with older adults, barriers to physical activity. And we basically interview older adults, ages 65 and older, right on up to 93 if I remember correctly. And we wanted to know what gets in the way of you being active. And they listed a whole range of things. So because that was an interview-based study using a constructivistic paradigm, qualitative methods, that is descriptive research. We're just describing people's experiences. That's what we were doing. Okay, so the second type of research question there, difference questions. Going back to my example of the BRFSS, you could plot differences between adults of different age groups in terms of the prevalence of arthritis. You can plot differences of adults, or males and females, in cardiovascular disease. You can say that there are significantly more male adults who self-report coronary heart disease than female adults. Those are difference questions. You want to know, are there significant differences between one group versus another on variable X? And it could be virtually any variable you can think of. Alcohol use, tobacco smoking, differences in physical activity. For instance, if you looked at the behavioral risk factor surveillance system, which is freely available, it's to anybody in the world can access this. This is your taxpayer money at work. You could plot any of these. You could look for any range of differences between different demographic groups on those risk factors and self-reported diseases. So a difference question essentially says, are there significant, oftentimes statistically significant differences between groups in a given variable? Also relationship questions, like for instance, taking that BRFSS data. Is there a relationship between age and physical inactivity? So we know that as people get older, their physical activity goes down. Okay, so we could say then, we could assess using the BRFSS that there's a significant negative relationship between age and physical activity. As people get older, their physical activity levels drop. So that's an example of a relationship question. And there are any number of other examples I could provide from the BRFSS about variables being related to one another. Okay, other examples. Well, is there a relationship between criminal behavior and outdoor ambient air temperature? In other words, in the summer months, when it gets warmer, does criminal behavior increase? It's a relationship question simply because neither one of those variables comes before the other one. We cannot necessarily determine that one variable causes the other. We just know that somehow they're related, that when temperatures go up in the summertime, criminal behavior also goes up. We can't necessarily say that temperature causes an increase in criminal behavior, because there are any number of other factors that could be at play, including socioeconomic status, the region of the country, unemployment statistics, any number of variables you can think about. So this is a key, and I will emphasize this again, this is a key lesson. Relationship questions deals with correlations or associations. Correlations do not equal causation. We're going to get into causation in Unit 3. But when we have variables that are related to one another, it does not necessarily imply that one variable caused another variable. Okay, proceeding to slide 5. Theory. What is theory? Think of an example of a theory in sport and exercise psychology. Does research support this theory? Well, there are a whole range of theories in the social and behavioral sciences, and sport and exercise psychology is no exception. There are good theories and there are bad theories. The empirical evidence available will dictate a good theory from a bad theory. Okay, so proceeding to the next slide, slide 6. A theory is a set of interrelated concepts, definitions, and propositions that presents a systematic view of events or situations by specifying relationships among variables in order to explain and predict events or situations. Okay, so a very common theory in sport and exercise psychology is self-determination theory. Self-determination theory predicts that people will thrive, be motivated, and actually have better mental and physical health outcomes when 3 basic needs are supported. These are 3 psychological needs, and they are the need for autonomy, perceptions of competence, and relationships. So self-determination theory, developed by Edward Deci and Richard Ryan at the University of Rochester, has a plethora of research to support it in the sport context, sport and exercise context. I use it quite frequently. So what it would say is that if you have a group of athletes and you support their autonomy to a certain level within reason, and give them choices in terms of perhaps scheduling of practices, the content of the practice, who they work with, you've provided them autonomy. You've supported that need for autonomy. If you are a coach and you provide them frequent feedback about their skills. You will support their need for perceptions of competence. And then finally, if you develop a meaningful relationship with your athlete or athletes, you will support their need for relationships. So those three basic psychological needs for autonomy, perceptions of competence, and relationships, meaningful social relationships, when they are nurtured on an athletic team, athletes will be more motivated and they will thrive. They will have better experiences on the team. Now note that I have not mentioned performance here, because that's a whole other question. But it's good to have motivated athletes. It's good to have happy athletes on a team. You ask any coach, and those are two essential ingredients. And so self-determination theory is very useful in predicting how and why athletes are motivated and happy on an athletic team. And there's a pretty fair amount of research out there. If you were to go into PsycInfo and replicate online assignment 3, punch in the words self-determination theory, athletes, sport, you'll probably find a couple hundred studies that have used self-determination as a framework to understand athletes' motivation. I use it quite frequently in my exercise intervention studies. So their theories can range. Now, most of us in sport and exercise psychology, go into slide 7, operate in mid-range theories, and I provided that example of self-determination theory as a mid-range theory. A micro theory might be a specific hypothesis. So for instance, if I want to apply self-determination theory, I might hypothesize that I could train coaches to use self-determination theory with their athletes, and if I would hypothesize then at the end of the season, if I trained a group of coaches in self-determination theory and then just followed another group of coaches, my hypothesis would be, this is a micro theory, my hypothesis would be that the athletes trained in self-determination theory, or the coaches trained in self-determination theory, would have athletes on their teams at the end of the season who would be more motivated. Okay, so that's an example of hypothesis. Essentially, your hypotheses are more specific examples of theories. So proceeding to slide 8. Basically, there's no single dominant theory in the social behavioral sciences. And in slide 8, I presented 4 theories: the trans-theoretical model, the social cognitive theory, self-efficacy theory, which is a offshoot of social cognitive theory, and then self-determination theory. There's a lot of good evidence for all 4 of those theories, depending on the domain you are focused on. So there's no theory that really totally explains human behavior, sport performance, exercise behavior, or any variables you might be interested in exercise science, sport and exercise science. They're all good. They all have evidence to support them. They all have their strengths and weaknesses, and we don't need to necessarily go into all that. Going to slide 9, choosing a theory. This is a difficult process. Now, let's back up a second. Let's go to Unit 1. Unit 1 quiz, which let me remind you, I generously opened that up to other people for you to take a second time. Why did I do that? Because that's the kind of guy I am. I allowed you to take it. I found out that some of you figured out that I didn't set the settings correctly on that quiz, and you were able to take it multiple times. That wasn't my intent. So since a few of you were able to do it, I figured I'm going to allow everyone to do it. Okay, keep in mind, quiz 1 is worth 1% of your final grade. 1%. So I'm giving you a chance here. Quiz 2 and the remainder of the quizzes, you will not have these opportunities. Okay, so why do I bring up Unit 1, Quiz 1? Well, basically because your paradigmatic or your philosophical assumptions guide how and why and which theories you choose to use. So, at the end of the semester, you're going to be asked to tie all this together in your capstone writing project, your research proposal, and you're going to be asked to identify a particular set of philosophical assumptions that you've adopted for your proposal. So, for instance, if you adopt self-determination theory or any other theory, it doesn't matter which one, and you're proceeding with a theory and you want to test a hypothesis about that theory, you're probably going to be operating within a post-positivistic or a positivistic philosophy, because a priori assumptions will be guiding your research proposal. But let's say you wanted to do interviews and you wanted to just know, you want to go in and study athletes' motivation and how their coaches, their relationships, athletes' relationships with their coaches affects motivation. You probably won't be going in with any set of assumptions. You might be aware of self-determination theory, but your research questions won't be specific enough to adopt a post-positivistic paradigm, so you might adopt constructivism. I hope this is starting to make sense. If it's not, I need you to come and see me or talk to me, because you're going to be asked to tie all this together very cogently in your research proposal for the signature class project. So oftentimes some theories and some theories are better suited for particular research problems than others. And so you need to really use logic when you choose a particular theory. You need to identify this not because it's interesting or in vogue or intriguing or familiar, but because it's logically related to the area that you're studying. And logic or internal consistency of the theory would be, does it seem to relate to the area that I'm studying? So self-determination theory fits very nicely into coaching behavior or classroom behavior, because it provides specific recommendations for how a coach or teacher should respond to his or her students or athletes. And so regarding the feedback that's given to them, the level of autonomy that they need in making choices to solve their physical or educational problems, and the nature of the relationship between the teacher and his or her students. So it does fit these, when I'm looking up at the slide now, choosing a theory, slide 9, it does fit very nicely into these 4 issues that I raise in bullet point 2. It appears logical and consistent for addressing issues related to coaching behavior. It's somewhat parsimonious, okay? It's plausible. On the surface, it appeared what I've described about autonomy, perceptions of competence, and relationships, seems to me anyways, very plausible. And most importantly, bullet point number 4, it has a lot of empirical support. In other words, scientists have been studying self-determination theory for a long time in sport and exercise settings, and it has empirical support. It's also very useful because, again, in my research, I've trained college students, undergraduate and graduate students, how to apply it with other people to promote exercise behavior. That's very useful. And ecological validity means that, essentially that, it is useful in real-world settings. It's not just something that laboratory scientists, or works well in a laboratory. It works in the real world. That's ecological validity, and we'll come back to that in another unit. But danger, 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 slide 10. Actually going out and forging a link between self-determination theory, the research that supports it, and helping coaches and athletes is not an easy process. As someone who has done applied sports psychology consulting with athletes and coaches in the past, I know this firsthand. It's not very easy. Trying to predict, nurture, and help people change behaviors, trying to predict human behavior, is a very difficult process. It's not easy. So forging links between theory, research, and practice is a difficult thing. Okay, proceeding to slide 11. What is a variable? Well, I've provided many examples. Proceeding to bullet point 3 in slide 11. What is the difference between an independent and dependent variable? You need to know this, and I hope you do from the readings. An independent variable is something we are interested in oftentimes manipulating. It logically precedes the dependent variable. The dependent variable is oftentimes an outcome we're interested in. It's just that, it's an outcome. So for me, exercise behavior and fitness are outcomes, or important outcomes. Those are dependent variables. I measure those regularly. The independent variable would often be mental imagery or some program or some set of educational materials that I think is going to have an effect or be related to that dependent variable, that outcome. So variables are vast. If you go into physiology, they could be stress cortisol levels, could be blood pressure, it could be resting heart rate or resting metabolic rate. It could be the presence of triglycerides in the blood or other lipids, which are, it's a fancy name for cholesterol. In psychology, it might be things like motivation. It could be goals that one sets. It's very important for you to then take those and realize the difference between an independent variable and a dependent variable. We're operating here from a positivistic paradigm, meaning if I am going to measure or develop an experiment to manipulate, let's say, mental imagery, exposure to mental imagery or goals, that would be my independent variable, and my outcome variable would then be exercise behavior or fitness. Okay, so you really need to know the difference between those. Sometimes it's not as clear-cut as you might imagine, but here we are talking about positivistic, post-positivistic philosophical assumptions. Extraneous variables are sometimes variables that mess things up. So for instance, if I'm developing an exercise program and it's an educational program for older adults, and it's let's say it's a 12-week program, and over the course of that 12-week program, all of a sudden a big new study comes out that gets a lot of media attention, and it shows that exercise is going to be the key to health and longevity. Those types of studies come out quite regularly, actually. But let's say it gets a lot of media attention, and a group of my research participants in the study watched that media report. Well, that's an extraneous variable. That might have an effect on their behavior. You'd say, well, that would be a good thing. Well, it would be a good thing for them, but it would not necessarily, it would mess up the relationship between my program, the independent variable, and what I am measuring, exercise behavior. Okay, there are other examples of that too. We will get into more about extraneous variables a little bit in Unit 3. Okay, slide 12. What is the difference between basic and applied research? Well, it's not always that clear-cut, but basic research is often viewed as bench science, conducted in laboratory settings where you might be measuring cholesterol, using sophisticated equipment. Applied research is oftentimes addressing questions in the real world. I'm not going to get too much into that, but Baumgartner does, and you better be prepared to answer these questions from Baumgartner. Again, I'm not going to answer all of the questions in this slideshow. I'm just trying to shed light on some of the important topics. What is the difference between quantitative and qualitative research? Well, quantitative research is basically going to use numbers, often statistics, measuring things, and that's going to get into the importance of measurement devices. And qualitative research is usually interviews, asking people about their experiences, their opinions, their attitudes, their values, their beliefs, etc. Now, what is the difference then? What then is the difference between experimental and non-experimental research? Experimental research, as we're going to explore in Unit 3 very in depth, involves more control over variables. It oftentimes involves randomization, and that's as far as I'm going to go right now. We'll get into that more in Unit 3. But randomization is when you, let's say I have this educational program for athletes, and I want to compare this educational program with a psychological skills training program. I would randomly assign athletes to one condition, the educational condition, versus the other one. And I often use a random number generating sequence. I might even use a coin flip to see which condition they would be in. Randomization is the hallmark of true experiments in the social and behavioral sciences, for reasons we'll discuss in Unit 3. Okay, proceeding to slide 13. I think this is a good time to take a break. I need to get a drink of water, and I will have a a second part to Unit 2 slideshow coming up.